Let's do an example involving what we know about derivatives of inverse functions that makes use of inverse trig functions. A couple of examples from now, we're going to be talking more about inverse trig functions. Let's get started now, since those are fairly important functions in calculus. So let's suppose that f of x is sine x for the restricted domain negative pi over 2 to pi over 2. You'll recall from chapter 1 that we needed to restrict the domain in that way in order to ensure that the sine function was invertible. We have to define a domain on which the function was 1 to 1. We used that domain, and when we restricted the domain in that way, we were able to define its inverse, which we write as sine to the minus 1, but we pronounce as arcsine. So we want to find the derivative using the inverse function rule. Let's use the derivative of the original function f of x, which is sine x, to find the derivative of f inverse evaluated at root 3 over 2. So first thing to take note of is that the point, well, actually, let me just write it this way. Arcsine of root 3 over 2 is equal to pi over 3. Why is that? Well, recall what arcsine is. The arcsine of root 3 over 2 is the angle in this interval whose sine is root 3 over 2, and the angle that fits that description is pi over 3. So what that means is that root 3 over 2 comma pi over 3 is a point on the graph y equals f inverse, in other words, which is we've defined as arcsine of x. So therefore, I think we've covered this, that the three dots in a triangle is mathematics for therefore. Therefore, we know that if I just switch these coordinates, that means that pi over 3 root 3 over 2 is a point on the graph y equals f of x, which was sine x instead of arcsine x. All right, so a couple of things that we can infer from this. First of all, we know that we can read off of this point, we can read that, let me do this in blue, we can read that f inverse of root 3 over 2 is equal to pi over 3. And the next thing we can do, since we know what f is, we know that f prime of x is equal to f prime of x is equal to cosine of x. And 3, we know that f prime of x is equal to, actually I already rewrote that, f prime of x is cosine x, f prime of pi over 3, which equals cosine of pi over 3, is 1/2. So now we should have all the information we need to answer this question. Let's make this a little smaller so I can continue to write. We know is that f minus 1, f inverse prime, in other words, the derivative of f inverse at root 3 over 2 by the formula is going to equal 1 over f prime of f inverse root 3 over 2. So that's going to equal 1 over f prime. We already saw here what f inverse root 3 over 2 is. So f prime of pi over 3, that equals 1 over, we saw what f prime of pi over 3 is, and it's 1/2. So this is going to be 2. So there's an evaluation of the derivative of arcsine at a particular point, which we got simply by knowing what the derivative of sine was.